Oh, the Sierra Canyon one? I want to. I don't know though. It's a lot harder for me to go to a basketball game not in our gym, but I'm not. We'll see. I don't even want to go and like have my little foot out on my thingy and trip up a guy.
But if it's not a guy from our school, it's okay.
Oh, okay. So I'll stop. 7.1 linear and nonlinear systems of equations. Kiddos, how have you solved? Well, hold on. What is a system of equations? No, it's not that bad. What's a system? Come on, I'm teaching my Algebra 1 kids this.
It is two equations with one solution.
Why next?
At least two equations with multiple variables. At least two equations with multiple variables that you need to solve. Why on earth would you need two equations if you're missing two unknowns? Oh, yeah. You don't have enough information if you only have one equation, right? You can solve one equation for one variable, or two equations with two variables, or three equations with three variables, matrices. Anyways, it's coming up back. How would you guys solve this linear one?
Yeah, you have
You could do
you can just have them.
Okay, you could do substitution. That'd be one way. That's what Caleb was saying.
Eliminations.
And if you are seeing you can just add down, then you are seeing elimination as well. Technically, back in the day in Algebra 1, you were probably also taught how to graph to solve, to find the intersection.
No.
But who wants to graph these lines? And the answer is nobody, even though we can, right? Think an algebra teacher when I goes on X plus B, hopefully. Okay, nonlinear. What's different with the next one?
It's parabolas.
It's parabolas. Elimination. I guess you could. I think I would probably instead think substitution. What would you solve for? X or Y?
Y.
Oh, definitely. However, what's something new that's going to come in to play that wouldn't be on the first one? You better use some factoring. Else we're going to be in some trouble. You better use some factoring, or else you're going to be in some trouble. Like not getting points or credit for understanding the problem. What does it take for an ordered pair to be a solution? It just has to work. But where does it have to work? In all the equations involved. It has to work in the system, it has to work in all the equations. Now, this doesn't show up super often in chapter 7, however, it still might. Remember, if you go back to check, and if it does not work, if the math said it did, but when you go back to check, it doesn't, what are those solutions called? That's the beginning. Extraneous. If you go to check and the solution doesn't work, oh my goodness. Here we go. And remember, those are called extraneous, meaning somehow in the process you ignored a restriction, and not on purpose, you were just solving, but you ignored a restriction like with a square root or with an ln or something similar. You ignored a restriction because you just undid it by squaring or by taking e to the, and you found an answer that the math said was like totally fine. But in ignoring the restriction, you didn't realize it was an illegal answer, so you sometimes, when you check, discover that not all answers that appear to be true actually are true solutions. So I just wanted to throw that quick word out there with extraneous. All right. Ready, set. You might have something as easy as this. Go. Wait, what? That's why it's only one day. How do you check a solution? They gave you the answer? Yeah. They're asking you to check it? Oh. Plug it in. Where? Everywhere. Does the top one work? Does the bottom one work?
Yes.
So the answer is? Hey, we like these. No wonder homework's due tomorrow, right? Okay, this isn't it. That would be so boring.
No.
However, it is a good practice of mental math.
No, you like those.
This would be great.
Yeah, I want that as my homework.
50 of these? It'd be so
Yes.
tedious.
Yes, but it would.
Good to speed
It would be
drill,
easy.
though. Speed drill.
Yeah.
Not
I'd
everything
rather-
that's easy is fun.
Well, yeah, but it would be.
It would be more fun than the regular homework.
That is true. I would rather do
It's like
50
playing
problems of
basketball
this.
against a kindergartner. You're gonna stop them every time. But
That's
that's really
actually,
you're just
actually, I wouldn't stop you every time.
That's hilarious,
Oh,
isn't
that's-
it? Oh, that's you can
Miss-
like
Miss
beat
Stewart,
them
the
up
sad
and
thing is I
stuff.
think it might be an even match between me and a 5
Oh,
and
dear.
5th grader.
But you're taller. Okay.
7 feet. What the heck?
But I'm incredibly athletic.
Now, hold on. Wait, there's a huge chart for substitution when really it's just plug it in. Now, hold on. Yeah. Do not dare write that entire chart, right? That's
Right.
ridiculous.
So,
However, I do want to give you some of the
Highlights.
wording because there's going to be basically one new. Back substitute is new. Okay? You solve one equation. Actually, I'm going to highlight one. You solve one. You substitute into the other. Solve the other. Back substitute. Go back and plug in to find the missing variable, and then you check. That's it. The hint is that you solve for the simplest variable, but that's something that hopefully your logic dictates based on your experience in algebra. The one that can be isolated most simply, of course. And if something cannot be isolated simply, you really hope that you can do elimination instead. Or you remember that sometimes you can multiply whole equations by numbers in order to make the math simpler. For instance, a system with a fraction. If you don't like fractions, alright, fine. Multiply by a number big enough to cancel out all the fractions. So sometimes you do substitution right away. Sometimes you say, forget it, let's go to elimination. Sometimes you say, ew, I don't like the numbers, let me do some cool math to make them easier on my eyes. Then you go do one of the methods that you like. So you solve one, substitute into the other, solve the other, then go back and plug in. Usually to your substitution step. And then check. And if it doesn't work, then you say it's extraneous. Well, hopefully you check your work first. And when you're confident your work is right, you say extraneous. Alright, you guys ready? Set and hold on. Nope, that's good. Wrong here. Okay. Shoot. Solve the system. Wait, what? I gave you the graph. Look, I even showed you. How many answers are there? How do we see solutions in graphs, kiddos?
Where the everything was stuff.
Yeah. For everything we have, which is two graphs and this one intersects. Well, wait a minute. Why are we using the math? That's dumb. Why don't we just graph it in our calculators?
I don't know. I would just
They're not trying to save us. Well, sorry, they're not trying to make us work harder. They're trying to save us work. Kiddos, if we were to graph these in our calculator, how would we get the graph to put into our calculator for the green line? What would we do?
You just put in negative.
Which one's green on the left-hand side?
Plus
Top one, because he's a
Not circle. The line.
He's a line. He's linear. Everything's to the first power, the y and the x. We can move the 1/2 x to the other side and we can make it minus 5/2. Alright, that's not too bad. That's y1. Question. How do we get the circle?
You just.
How do you plug it in?
The other
Don't
one.
you need y by itself? Uh-oh, why am I writing y2 and y3? Ugh. How do I solve for y? Yeah, how do I solve for y, guys? X squared's not positive, you move to the other side. Make sure we're staying on topic, guys. How do I solve for y? Oh, but what kinds of square roots?
The difference.
I need a positive square root for the top half of the circle, I need a negative square root for the bottom half of the circle. Who can help me out as to why I need to write this in function notation, why I need two different square roots to make my circle? Nope, we can't do that, you're killing puppies.
What are the answers? 5, 5, 0.
Question, guys, why do I need two different functions to express a circle?
Because there's plus or minus.
What happens to the vertical line test for a circle?
Oh, fail.
It fails. Can a circle be one function?
No.
No, it has to be a combination of at least two. Okay, so some of you guys are going to your calculators and you're like, yeah, I'll do that. I'll plug it all in. I'll solve for all that. Okay, I guess if you wanted to and you were allowed to use your calculator. But how could we do it with math? How?
Ask your neighbor.
Oh my goodness. Substitution sounds great.
Ask a shop.
Not elimination. Some of you are just giving up. Substitution. Now, how many of you are like, ew, I don't like fractions? Oh, come on, there's a lot of you that don't like fractions. I know that. That's all right. Why am I multiplying by 2?
Oh, because that makes the twos go away.
Yeah, some of you guys like it better. It'd be negative x plus 2y equals negative 5. Is it nicer for any of you?
Mm-hmm.
What would you solve for now? I don't know, the x maybe? For substitution? So we could add the x, we could add the 5, we'd end up with, from this, x equals 2y plus 5. Anybody tracking? Now that I have this, I'm going to go ahead and go find where he is, he meaning x, in the other equation, and plug it in, right? So then I end up with, we solve for one, did a little bit of math here in the beginning in order to make things a little bit easier so we didn't like fractions. Now we're going to plug in 2y plus 5 for x. We were talking about basketball a second ago, right? X comes out of the game, 2y plus 5 comes in, substitute. The x has to be gone if something's substituting for him. The math says solve. The only way to solve is to go ahead and FOIL everything out, combine some like terms if we need to. We can subtract the 25 from the left-hand side by moving him over. The nice thing is in this one it cancels all out. 4y squared plus 1y squared is
5y squared.
got it. The 25s cancel each other out. Can't we just factor out a 5y? Oh my goodness. We have y equals 0 and y equals 4, right? Gracias. Y equals 0, y equals negative 4. What are we going to do with both of those? What are we going to do with both of those, guys? Back, substitute. You guys catch that wording? Go back. Plug it in. Where? Who's just waiting to be plugged into?
Everyone.
Yeah, he's chilling. He's waiting. He's saying I'm ready. Let's go back and plug him in. Mental math. If you can do it carefully, it'll save you time. 2 times 0 is 0 plus 5. X equals 5. 2 times negative 4 is negative 8 plus 5 is negative 3. Some people might have time as well. 5, 0. And negative 3, negative 4. Dun, 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 dun. Does that match up with our picture up here? Why, yes, indeed it does. 1 and a 2 and a 3 and a 4 and a 5. That would be our 5, 0. And then we have a 1 and a 2 and a 3 and a 1 and a 2 and a 3 and a 4. Negative 3. Now granted, some of you might be like, hey, the calculator sounded easier, cool, because you've gotten all the way there on your own with the plus or minus square root and then putting into 3 different functions, and you would have kept going and persevering until you found all the intersections. Maybe. Some of you are like, maybe the math is easier. Okay, let's go do another one. But do we have our answers? Any quick questions on this problem before I move on? Jackie?
Instead of plugging into the equation with the x equals 2y plus 5, can you plug into the x squared plus y squared plus 5?
Well, I did have to plug into the x squared plus y squared equals 25. Do you mean solving that one for x or y?
Solving for x, if you plug it in, you plug the y's into the equation. And it's gonna find it.
Oh yeah, you could have solved for y instead. Is that what I see. So when you have y equals 0 and y equals negative 4, you could have plugged it in technically 3 different places. You could have plugged it in either right here where we did, you could have plugged it in right here or right here. All of them are valid because in all of them it must be true. So whichever one you like better is totally fine. Okay. You guys have fun. They're linear. Oh, come on, they're linear. Don't go to your calculators. Come on, you can do the math. It's faster. If you don't like fractions, use my trick. Multiply both sides by one single number. That'll get rid of one fraction. Or be super snazzy and multiply the bottom one by 3/4 and the y terms will cancel out. Depends on whether or not you fear the fractions. That's alliteration.
Amazing observation.
That was alliteration. Now if we could plug in synecdoche or something like that, that'd be fun. Synecdoche, come on, that's one of those literary terms you guys memorize in and or an EP. Did you guys have a list of literary terms in EP to memorize?
We're supposed to, but I don't memorize
That's
them.
fine.
Synecdoche.
Oh,
That's I always remembered synecdoche because it has neck in it, and it's something about how you talk about one small thing to, like one part of the body to symbolize the entire. Something like that. Like you use a part to symbolize the whole. You should memorize those.
A
They
part
show up on
of
the
your
test.
body to symbolize your whole, or a part of another
You
body?
can do like a part of anything to symbolize the whole.
Like, I know.
I can think of an example right now. That's really help.
We're just trying to figure this out.
It's not one.
Hey, how do we get rid of fractions?
Multiply.
Just add.
You can just go ahead and multiply this guy by 3/4 and say, yay, let's go, but most of you are scared of fractions, so I'll do it your way. How'd you get rid of all of these guys? Probably with the 4, right? How'd you get rid of all those guys? Probably with the 4. You end up with, you gotta distribute. 4 over 2 is 2x plus 3y equals 40. This guy can turn into 3x minus 4y equals 16. I know some of you are like, ugh, you have to multiply again to make them match, but others of you are like, yay, no fractions. Whichever way you like. Elimination says make a match. Who wants to do substitution with this? Ugh, not me. So what do you guys think? The opposite signs, let's go for those ones because they're already opposite. So I'll multiply this guy by 4, I'll multiply this guy by 3. Remember, I'm considering the fraction codes. Double check my math. Is it turning out alright? I have my 8, I have my 12, I have my 160, I have my 9, I have my 12, I have my 48. Good. Finally, 17x equals 208. X is equal to divide by 17, divide by 17. It's not a pretty fraction. Check the big ugly decimal. Did it simplify at all? Nope. 208 over 17. Did you guys solve it another way and get the same answer? Everybody was afraid of fractions?
Yes. These are fine.
That's no fun.
If you multiply one equation in the system, you have to do the other one by the same number.
No, but you do have to, for one equation in the system, remember you have to multiply both sides of that equation. But no, we totally did this one by 4 and this one by 3 because we needed the numbers to match. So we did 2 different things. Once we have x, what do we do? David, where can we plug it into?
So you can plug it into first two equations or any other way.
Exactly. You can plug it into anybody. You can plug it into anybody. So what do you guys want to plug it into? 2x plus 3y. I was thinking that one too. So we have 2 times x, which is 208 over 17, plus 3y equals 40. Any mental mathers? You get 416 over 17?
Oh,
17.
Calculators that solve the equations.
Oh, yeah. That's right.
Okay.
17 times 40.
Sorry, I was distracted by over here. So we have 17, and then we have a 0, and then we have an 8, and then we have a 680.
Yes.
Oh.
So we subtract our 416. Get rid of him. That'll give us 3y is equal to 264. 17th, is that right?
Yeah, 264.
Divide by 3, which is the same thing as multiplying by 1/3. Does 3 go into 264? Ooh, it does. Y is equal to 3 goes in 88 times. That's what I got. Has anybody been double checking?
Well, the
So that's
one was y, so the first one was.
Matt, you say yeah?
Get 8 instead of 5.
Can you graph? I was trying to do it in mental math because otherwise you're going to do a calculator and I don't know. Some of you would rather just go to your calculator, but I'd rather just go to math. If I can. David.
Why do you multiply 17?
Ah, you see it? Because I wanted to try to move him to the other side by subtracting, and I wanted this guy to be in 17th when he came.
Okay.
I was just trying to get common denominators a little bit early. Whew, man, the math's getting a little bit fun. Hold on. What do these two tell you to do? Like, tell you to do. In the directions they instruct you to do. Use your grapher. Oh. Okay, well, if you use your grapher, specifically number 45, I've already done it, guys. I've already graphed both of them. In the sense that you can make one of them y1. You can solve this guy and get y by itself, and you would end up with y equals x plus 1 after you solve y2. You just have to graph your y1, graph your, nope, that's not y1. I apologize. y2 is your line, y1 is your exponential. You find the intersection, you can say, sweet, I have the answer. No big deal, right? Is there any other way to algebraically solve that one?
Yeah.
Actually, to be honest, no, there's no algebraic way to solve it, at least not easily without approximating. So sometimes you have to use your grapher. There is no other way when the functions get messy enough, when the system gets messy enough. Hopefully they'll direct your attention to that though by saying something like use the grapher. And to be honest, kiddos, in number 43, you could go to all the work of solving for all the y's, the plus or minus square roots. Or for instance, on the first one, couldn't you say, hey, I know that guy. Who is the first equation? He's a circle. And so if you're like, all right, I'll give you that. I think I maybe should have known him to be a circle with a radius of 5. But how on earth am I supposed to know what to do with the second one?
Graph.
Actually, I probably should say y1. I'll just keep it red. How do you graph the second one? He's not a circle. Who is he?
Parabola.
Mm-hmm. Couldn't I solve for y is equal to 3/16 x squared? Double check. Subtract the 3x squared, divide by the negative 16. Oh, how are we supposed to graph that guy? Well, plug in 0. Don't we get 0? He hasn't been shifted anywhere. Don't we know he's concave up? What's something to plug in that would make it nice and pretty as a number?
1. I don't know.
How about 4 or negative 4? Why am I looking at those guys?
Because of the 16.
4, -4, we get 16. 16s would cancel out. Wouldn't I get 3 for both of those if I plugged in Chuck? Now I know. I'm cheating a little bit. I'm looking at the number and saying, hey, I know somebody squared who's 16. But what do we end up getting? 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4 to the left. 1, 2, 3. Yes, you could have used your graphing calculator. I'm just trying to show you that's not always the easiest way. We end up with the final answers of, I already wrote them down. Don't do like that. But once again, they say to solve the system graphically. Some of the equations maybe you can do from our library of functions in the back of our minds, the absolute values, the parabolas, the cubics, the circles, etc. However, you can also use your calculator as a backup. Anything else?
No.
Oh, there's some application-y ones that might be easier if we looked at just for a little bit. Does anybody have a book nearby? Guess I didn't have these ones down. Thanks, Jacob. He's passed over.
What a champ.
Break even. Has anybody ever heard that phrase? Break even. What?
Break even.
Yeah,
What about break even?
Gambling.
Okay, well, let's think about that. Gambling. How do you break even?
You don't lose money.
The money that you spend equals the money that you
Got that.
Didn't lose.
Got that. So if you bet 20 and you get 20 back.
Yeah. If you bet 20, you get 20 back. Another way of thinking about it is,
You know too much. Too much.
oh, I was thinking the money that you spend. Never mind. See, it has something to do with what you lost. Like the total money that you win, there we go. The total money that you win equals the money that you lost. Is that another way of breaking even?
Yes.
But that doesn't break even because still you lose some of that money that you spent. Anyway, whatever.
But if
There's
you make
another
the money,
one.
If you make the money that you lost, then you break
Yeah.
even.
Yeah, but then you spend a bunch on all of the
But you
services.
spent the money on it.
If you lose
No, but you
20,
get
but then
it
you make
back.
20
Yeah,
back,
if you get it back,
Okay,
and
okay.
then you break
So I was thinking the money that you spent
Nah.
equals the money you get back, and the money that you win equals the money that you lost. Okay, long story short, gambling, that's great and all, but how about business?
Nah, business is
No,
like
business
little
is
more
basically just
legitimate.
it's a gamble.
It's
but
legitimate gambling.
It's-
Okay,
yeah.
pause.
He's got a point.
So, take what we were talking about with gambling and apply it to business. What would be the snazzy way, you're not in economics, most of you, however, think about breaking even businesses. What do?
You're doing poorly.
They invest, they spend, now, or they pay for like cost of operation, they pay for cost of materials, they pay for like their employees, etc. They spend, but then they also hopefully make, okay? So breaking even is ultimately when your overall cost is equal to your profit. Now guys, if you're a startup company, right away, you go in the hole, right? To start a company, right away you're spending money without making anything, right? The doors aren't open yet, you have to like start renting a place, you have to get everything set up, now maybe you have investors, etc. But you're in the hole until the doors open and hopefully you start doing what?
Poorly.
Making money. Breaking even is that point where it's like, okay, I'm going out on this venture, I'm like investing all this money. Breaking even is like, whew, I just made up all of what I spent. Then you can go ahead and everything above that will be the profit from there on out, which hopefully that will continue to grow. So you set the cost equal to the profit. On number 59, I'm not going to solve the whole thing, but what's the problem give you? A small software company invests $16,000. Question, does that go into the cost category or the profit category? They invest $16,000 to produce a software package. That's cost, right? So right now we're just trying to figure out what's cost, what's profit. So they spent or invested $16,000 just to get this software done. The software will sell for $55.95 each. What's that? The software will sell for $55.95 each. Profit. Each unit costs $9.45 to produce. What's that? Cost. See, this is their startup money. This is what they had to spend in order just to get this thing done, made, have their employees working on it, whatever. How do we set up an equation that says, hey, when do they finally break even and they make up all the money they spent to get this thing going? How do we say each in math? No. In a mathematical equation, do we just write the word each? No. Times a variable x, however many software packages they're selling, right? So the question is, how much do they have to sell in order to break even and hopefully finally start making some profit? And if you look at this, there's no salary involved here. So business gets a bit more complicated. Or rental costs, or business costs, or online website costs, etc.
Like gambling's easier.
Yeah,
He's got a point.
not chancier.
I mean, you're not paid where you got pretty decent numbers.
Talk to someone who's been doing it for a long time. There's a lot of payment that comes from that.
But there's also a lot of gain.
There's a lot of-
See, I got you there.
There's a lot of potential
I think
gain
I
in
need to
everything.
start let's get down to Skid Row and take tacos and talk to some of the people with stories.
Some
You're
tables
gonna
are
need
like
Tyler there when you come back.
35 times the
Number
original amount.
66. Maybe I'll point you to the Bible. We'll have some verses for you. Talk about gambling too. Number 66. The perimeter. That's where we're supposed to go for our truth, right?
What? Do a casino.
What if they give us hints about a couple different things? Like the perimeter is 42 inches. And the area. Oh, they don't even tell us anything about area. Never mind. They tell us another clue. They tell us the width is, in math, that means equals, right? The width is 3/4 the length. How do we use these clues? Why is this in the systems section? Ooh, more alliteration. Yeah, because what do you know about perimeter and rectangles? Come on, kids. Yeah, there's 2 widths and 2 lengths. Perimeter is add the distance around, so I have 2L plus 2W. They told me perimeter is equal to what? What would you use to solve? Hopefully what I would use to solve, which is substitution. Plug it in, right? So systems of equations, guys, they show up all over the place. It's not like one section. It's really just like one tool that applies to all sorts of different scenarios. So we introduced it in section 7.1. I'm doing math while talking. It's very dangerous. 2 is the same thing as 4 halves plus 3 halves is 7 halves. You guys know by this point, hopefully, right? How do you get rid of 7 halves? Divide by it? No, what would you do? Multiply by the reciprocal. You guys stealing my time. We still have 60 seconds left.
Wait, why can't you
Does
just
it say
multiply
16
everything
or
by
16?
2 then divide by,
Wow.
Still a whole minute.
That was a competitive thing to say.
And then, remember, there's this equation just waiting. No need to get lost. Go back and plug it in. Mental math, what's it equal?
Oh, wait, no.
Oh, come on, kiddos.
No, it's 3. No, it's 6.
Why are you making it so hard? Why didn't you reduce and just get 9?
Yeah.
Yeah.
Dun-dun-dun.
Yeah.
Oh, because 3 times 3 is not 6.
Dun-dun. Kiddos, homework due tomorrow. Shoot. Section 7.1. You still have 30 seconds. Sit down. Oh my goodness, you're worse than my algebra kid. I had been better trained. I've only had them like a month.
Yeah, we want to hear Mr. Carmine speak.
That's good. 7.1, number 42 is due tomorrow. Don't get lost and don't run over any little kids. Or otherwise, you're going to have to later.
Don't run over.
Whole 10 seconds early.
Holy cow, my back just broke.
By the time you get to the door, it's only 5 seconds.
The clock stops.
Oh, yeah. Wow. I've never.
Yes, I have never. Are you a part of this?
What?
Cool.